Okay, so let's continue with this imaginary variation on Peggle that we're trying to make here. So I'm picturing that as these pegs start falling from the playing field, it might be fun to try and catch them in our bonus chute. And one way we could do that is to control this chute with our mouse. And let's look at how to do that. If we go into our bonus chute actor, it turns out that most of this is going to be pretty easy because we've done 90% of the work already. By starting with an ideal location where we want our chute to travel to, we've pretty much set up the process to get our chute to actually move to that location. So all we're going to do is change our ideal location so that instead of it being a point that gradually moves across our screen, it's just going to be a point determined by our mouse. So I am going to, let's just comment this out first so we have something to copy. And I'm going to set up my new ideal location, which is a B2 vec2, and it's still going to be a new B2 vec2. But this time I'm going to take our costumes X, and I'm going to add to it our costumes.mouseX. Now you'll remember that our mouseX, defined in terms of sprite, is relative to that sprite. So in other words, if my cursor is 10 pixels to the left of my bonus chute, my mouseX will be -10. It won't be whatever that mouse coordinate is on stage. And so by taking our costumes X, adding to it the mouse X for that costume, we can basically determine what that point is, say 10 meters to the left of our costume. Hope that made sense. And then our ideal Y position is still going to be this Y position variable. Wait, is that it? Holy cow, that was easy. Let's, just so we don't confuse ourselves, I'm going to delete this. And because I've made a backup, I'm going to delete all of this code that moves our direction back and forth. And let's run this and see what happens. Well, if we look at this, it's looking pretty good. Our chute, as you can see, is following the mouse, and it seems to be doing it pretty well. But, okay, that's a little funny. You'll notice that as our cursor gets all the way to the left and then keeps going, it seems like our chute is doing something sort of strange. It is no longer hugging the left wall. It's actually moving out a little bit. And if I'm able to get a ball or a peg to react with the chute in this state, you'll see something unusual happen. All right, I'm going to jump ahead in time here and there you go. I don't know if you saw that. I don't know if that happened too fast, but when that peg collided with the side of my chute, it didn't react in a normal way. It shot halfway back up into the playing field. And so something weird is clearly happening. And basically what it is that as my mouse keeps moving to the left, my chute is going to want to try and set its velocity so that it can remember that my chute is acting in a way where it wants to align its center to my mouse cursor. And obviously if I start to move over here, my chute can no longer align with this mouse cursor because there's this wall in the way. And so what's happening is, say if my mouse cursor is here, my chute is over to the right, it's trying to move very quickly to the left in order to move to where my mouse is. It's trying to do that, it's colliding with this wall on the left-hand side, and that's making it bounce out. And so what's happening in between frames and happening so quickly that you don't even notice is basically that my chute is colliding into the left side wall very quickly and then colliding out again. And so that's kind of why we're getting this weird behavior, and that's why if you see a ball collide with it, you'll notice some sort of unusual things going on. So this is actually a very easy fix. I just need to make sure that I'm not trying to move my chute further to the left or to the right than it ought to be. So basically I can do this bringing back our bounds array that we were using to record the leftmost and rightmost side that we wanted our chute to travel in. I could do this in an if statement, something pretty obvious like if ideal location x is less than bound 0, ideal location x equals bound 0, else if ideal location x greater than bounds 1, ideal location x equals bounds 1. alternately, I could actually specify this as ideal location x equals math.max of ideal location x bound 0 and equals math.min of ideal location x bounds 1. I suppose these are both two ways of saying the exact same thing. And if I felt like being incredibly clever but obscure, I could say it's math.min of math.max of ideal location x bound 0 bounds 1. These are just three different versions of saying the exact same thing. I find this one too confusing. If I come back to this in a month, I'm going to forget what it means and probably a little too error prone. This top one is perfectly fine if you want to use it. I kind of like using this middle one. I've used this enough that I'm used to it and I understand what it means. But like I said, any of those three variations will work. So let's run this now and see what we get. So let's see here. All in all, this is looking pretty good. It looks like my bonus chute is still properly following my mouse, and when I get to the extremes of the playing field, it is just stopping at the edges instead of continuing to try and follow my mouse and ricochet off the sides. So that's much better, and this will still react very well with all the moving objects in my playing field, no matter where it is on the screen. So I'm much happier with the way that performs. So I guess next maybe let's deal with these strangely balancing pegs, and that'll be coming up next.